Good morning, good day, and good evening. I'm, as always, your host, Brody Robertson. Today, we are not doing a solo episode, and we have a very interesting guest today. So, how about you introduce yourself? People probably know one of the projects you've worked on, but they might not know the face behind it. So, yeah, go ahead.
Okay, so hello everyone. Brody, thanks for having me.
Absolute pleasure.
My name is Andrey Breslav, and if anyone knows any of my previous projects, that will probably be Kotlin, the Kotlin programming language, which I worked on from its inception in 2010 till 2020. So we went from nothing at all, and an idea basically, to millions of developers using Kotlin. And it was an exciting journey. So I was in charge of designing the language, building a huge part of the compiler, running the team, did quite a lot of public speaking. So if you've ever seen me before, it's probably from those talks, or maybe super recent things I've been doing in my new company. I currently run a startup called CodeSpeak, where we're basically continuing what we started doing in Kotlin, where the idea was to raise the level of abstraction, make programming nicer for people. So here we're trying to do the same thing again, but on a new level, using LLMs, trying to elevate programming to the level of human language. So CodeSpeak wants to be this new generation, what comes after vibe coding, let's say, and that's our mission, more or less. So recently I've been talking a lot about that, and I imagine we'll talk a little bit more about how it works in detail.
So I think a good place to start here, just as a refresher for anyone who might not be aware, when you say the phrase vibe coding, what do you mean by that?
Okay, so it's actually an excellent question, because different people mean slightly different things. I think the sort of narrow definition of vibe coding is very literal. When you go off the vibes and you don't really look at the code, and there is a coding agent, and you kind of hit it
Just
with
wing
your
it, throw it out
ideas and sort of get a prototype that you can iterate quickly and throw together something working. And you go with sort of LLM's ideas more than you might if you were more serious about this project. So this is like a narrow definition, but there's also the general idea of coding with an agent as a solo developer, not necessarily working solo on the project, but here and now you're one person in front of a coding agent and you're prompting it to build code for you. And this is how a lot of serious software is being developed right now. A lot of people use Claude Code or other agents at work. And this doesn't have a proper name, like agentic coding, I guess.
That's a fairly recent one. It's kind of catching on, but a lot of these terms are sort of appearing and disappearing. We haven't really got this clear terminology yet. That's going to be something that sort of irons out over the next couple of years, I would assume.
Yeah. So but there is this mode of operation when you are a developer who's working on a serious project that's not like a one-off thing that you're throwing away. And you're using a coding agent as your single player tool on your machine. And then speaking of terminology, there is another term that's kind of catching on right now. It's agentic engineering. And I guess this is more of a concept right now than an actual phenomenon, but people realize that what we have right now with this very narrow mode of using agents to write code on your machine has to scale somehow to the actual software engineering level when you build the entire system, you communicate with other people on the team, you have long history in your project, you have processes, you have quality concerns, and so on and so forth. So these things, the word engineering is very important there. And basically, this is the world that we're building CodeSpeak for. So the initial idea, before I heard the words agentic engineering for the first time, the idea was to try to imagine this world and try to build for it. And the very early sort of concept of CodeSpeak was, if we take software engineering and stop writing code by hand, what's left? Like, what's the engineering part of it?
Right.
Like, there is, some people call themselves coders or software developers, and some people call them software engineers. And what's like, is there a conceptual difference there? And if code gets written for you, are you still an engineer? And my answer is yes. And we want to capture this engineering aspect and make tooling that's good for it.
Well, the obvious question there is how? If you're using CodeSpeak, what are you actually engineering that this is still engineering?
Yeah, so that's a very good question. So I'll go with like what you're engineering first, and then go into how CodeSpeak is trying to address this. So if you think about like the evolution of how people made software over the years, there were like lower level languages, and then we raised level of abstraction. So the C programming language, for example, was considered a high level programming language at some point.
Yeah,
nowadays it's very low level.
A bit of a tangent, but like that's something a lot of people completely forget about who don't know any of their programming history. That was a big abstraction. You can actually go find writings of people back then who speak about C the same way that people now speak about a language like Rust.
Fair, yeah, and also like Rust is not the highest level possible.
Sure. It was just a popular example.
Yeah. So and back then C was basically coming in the place of assembly languages, and people who were used to coding in assembly would take a C compiler and like compile their code, and then look at the assembly that was generated behind the scenes and be like completely appalled by how ugly it was. And this is something you can absolutely recognize in today's agentic coding, where you're a programmer trained in whatever languages, and now you generate this code, and it's kind of ugly. If you look at it, it works, but it's ugly.
Right.
And this is completely history repeating itself. And we had this, like, if you think about, Java virtual machine emitting code at runtime, the kind of code it emits may be like mind-bogglingly weird and not very nice, but it works, and it's even performant a lot of the time. So, we've had this multiple times, and now we are at another sort of cycle of raising the level of abstraction and being slightly appalled at what kind of code is being generated.
As a very approachable example, if anyone wants to experiment with this idea, if you understand any basics of web development, go and use a drag and drop web editor and then look at the HTML it generates behind the scenes. And you will have no idea why it works, but it probably does work.
Fair, yeah. So this would be sort of the previous generation of like no-code tools, right? Were those like template-based drag and drop editors. And nowadays we have agents. I don't even need to drag and drop anything. I can just say what I want, and Claude builds something for me that kind of looks nice and can work. Yeah. So why I brought this up was that throughout the years, different like programming paradigms changed, and we went from assembly to C to Java to Kotlin to whatever. But some things stayed unchanged throughout the entire thing. People kept talking about dry, about solid, about kiss, things that are like fundamental principles of, basically let's organize what we're working with, organize our systems in a way that's easy to maintain, easy to modify, easy to extend, so on and so forth. And that's engineering. And interestingly, that's engineering even out of the context of software. It's engineering in general. Like in electrical engineering, you have absolutely the same concerns where you're building something complicated and you really want it to be sort of logically organized and be maintainable and extendable and whatnot. And this is engineering as such. Like you can distill the engineering aspect out of any engineering discipline. And there, this is what we're after. Like, if we get to the level of smartness of agents, where code is solved. We're not quite there yet, but we're getting close. Like maybe code gets solved at some point. The engineering aspect still remains. We still need to organize our understanding of the systems in a way that we can keep evolving them. And the interesting thing about this is that, maybe models get very smart. Maybe models can have huge memory and not really care about things being logically organized because they can keep track of everything and so on and so forth. But the thing is, maybe it's even hard to predict what kind of models we get in 5 years. Maybe they're super smart. Maybe they're a little smarter than now. I don't know. There's another thing I do know, though. 5 years from now, humans will be the same.
Sure.
And if, as a human engineer, as a human author of a system, I am my today's self, I still need the logically organized complexity. I need to know that my system is, subdivided in modules I can navigate. I can understand the levels of abstraction, because otherwise it doesn't fit into my mind. And that's the thing. This is why engineering survives. Humans don't have infinite memory. Humans don't have infinite conceptual power. They need well-organized concepts to navigate the complexity of the systems they're building. And, obviously, when we get better tools, we start building more complex systems. And we've seen this over the years. Early computer systems were tiny programs compared to what we have now. Now we can build, payments infrastructure that spans the entire planet, and it's incredibly complex. With more power from LLM code generation technology, we can build even more complex systems, and there is a lot of complexity in the world that's not automated yet. So we will be building those systems. We will be getting nicer level of automation, which will increase complexity quite a lot. And for us, as the ones who want these systems and know what they want, it's crucial to be able to keep in mind where we are and where we're going with the system. And to do that, we need the engineering discipline to organize our understanding of it.
So you see the position of the person as this, I guess, director of the model, the director of the AI system, rather than... there is this... as we talked about earlier with the idea of vibe coding, there is this idea that floats around where at some point you fully replace the human in the equation and you just let you let the model go off and do everything by itself. There's been these experiments where you've let these AI models go and try to build a web browser by themselves, and they can somewhat approximate it, but you see the position of the human in the middle here as someone who can keep this system organized into a logical infrastructure that is actually able to be extended, I guess.
Yeah, I think you're asking a very important question here. So the thing I kind of didn't even mention is why we need the human there at all. And so as soon as we need the human in the picture, the human will need the logically organized system. Because it's our need. Why we have the engineering discipline at all is because we as humans need it. Right? So, but the question is, why do we need humans there? And there are a bunch of different sort of angles at this. One is that, you can tell a model to build a browser because it's very well known what a browser is. We have existing browsers. We have standards that describe what browsers do. We have benchmarks. We have tons and tons of things that define what a browser is. You say one word, and we know what it is, and the model knows what it is because it has this public knowledge, right? But if you want to do something else, something that hasn't been built before, it's not the problem of creativity of the model, but it's you who wants to build this, right? So
for something new, you need to be able to break down the problem.
Yeah, you need to explain what it is that you want built. Even if the model isn't infinitely creative, which it isn't, even then, if you are the author, in the sense that the intent comes from you, you have to express that. And if it's something non-trivial, the explanation will not be short. And you will probably be iterating, and you will be understanding better what you want to build as you go, and you will get user feedback and refine your ideas and so on and so forth. So this definition, this description of the system will evolve. And to evolve it, and it's going to be a big one, right? To evolve a description of a big system, you need it organized in a way that you can navigate. And probably you will not be working on that alone because, again, like one human head can only contain so much information. You will have colleagues, and together you have to navigate this complexity, no matter whether it's expressed in a programming language or in a human language. You still have to navigate it.
Okay. So I guess, do you want to get into how this is being, like how you do this with CodeSpeak, or is there more you want to say on this before we get there?
Yeah, I mean, I can just mention one small thing. You can still think about kind of removing humans from the equation altogether somehow. Like models get very smart and they figure out what's needed on their own. I think there is a very important thing that a lot of people kind of either miss or don't want to talk about when mentioning this. If you have any situation where models make all the decisions, like humans are not involved, this means that models have taken over.
Right. I've seen a couple of movies about this.
Right. So it's like literally taking over means being in charge, making the decisions. That's what it is. And you may be super optimistic about the world where models take over. I'm not. Generally, I don't think it's a good scenario. And this is why my basic assumption is that whatever I'm building for a world where models haven't taken over.
Right.
If they have, that's not a scenario that any business is relevant anymore.
Right. That's when we start entering the world of the paperclip optimizer.
Sure. Well, I mean, it can be much smarter than a paperclip optimizer. This is sort of a very narrow example, but in general, if models are in charge and not humans, human businesses don't matter anymore.
Sure. So for anyone who might not be aware of what I assume most people probably have heard of paperclip optimizer. For anyone who hasn't, the idea is you tell a system to create paperclips, and it tries to continually optimize this task to the point where it starts taking every atom in the universe to convert them into paperclips, because it is the most optimal way to create paperclips. There's a lot of steps along the way to get there, but you can look it up and you find a video or something like that.
It doesn't have to be this narrow. If any alternative intelligence takes over, it has its own goals.
Right.
And it's very likely that humans are not very instrumental to achieving those goals. Goals may be infinitely more complex and interesting than paperclips. It doesn't matter what they are. But humans may not even be part of the picture.
Right. We don't fully understand there's already been these sort of cases of these models communicating with each other and then generating their own languages from it. So we're not entirely sure. We know the input of the model. We know, we can look at what goes on in the center. We're not entirely sure for these really big complex systems. At a small level, we can fundamentally understand the maths behind it. But when we get to the scale that we're dealing with now, as you were saying before, there's just, you need, sorry, I'm jumping around it. There is only so much that a person is able to understand by themselves, right? So when you start dealing with these giant models that we have now, and they're only going to get bigger, we don't really know what is going on internally.
True. Yeah. So, we're kind of on a tangent right now,
yes.
talking about the risks of AI and whatnot. Yes. I think the useful keywords there would be technological singularity, instrumental convergence, and mechanistic interpretability as one of the ways people are trying to address this. I'm not a huge expert on either. So
sure.
The basic concept is, my assumption when I'm working on anything is that I'm building for a world where this hasn't happened. Because if this happens, I don't know what's relevant. Nobody can predict what's relevant.
Fair,
and it's very likely that nothing we can build is relevant.
Mm-hmm. Well, let's segue back into the main topic then.
Yeah, sure.
So, CodeSpeak. I guess.
Right. So,
how does it
go
work?
ahead.
If you are engineering a system here, back to what I said before, what are you actually engineering?
Yeah, so I think we can use the analogy of going from assembly to higher level languages here. And the role of assembly in our present world is traditional programming languages. So TypeScript or Kotlin or Java or whatever is this like sort of previous generation language that all software is built with. But we can now work on a much higher level of abstraction. Even with agents, raw, without any CodeSpeak, you can already express what you want in human language and get working code. Like, it's hard to get really good code, whatnot, but still, you can definitely raise the level of abstraction. You're not entering like specific programming language constructs anymore. Very many people say they don't write code by hand anymore, which doesn't mean they are not thinking about code, but it means that they are not like typing in a code editor and like using code completion. No, they're prompting an agent. They are reviewing its code. They maybe make tiny modifications to that. At least this is how I work. So we are in the process of raising this level of abstraction, right? So we're transitioning from traditional programming languages to human language, which is a huge leap. So from our early experiments, if you try to write down sort of a specification document, some kind of natural language document that describes what your code does, and in such a way that a model can generate equivalent code from that description can easily be 5 to 10 times shorter. And we did some measurements, and it's not a huge data set, but still, it looks like going 5 times shorter is trivial, 10 times is often possible. So, and this is incredibly beneficial because if we have 10 times less information in there, we can navigate a lot more of it in total, right? So this is the premise. Like, it's worth transitioning from programming languages, traditional programming languages, to this human language representation of the same system because it's a lot more compact. So it fits into your mind a lot easier. You can be quicker at grasping the concepts, so on and so forth. So this is what we're trying to facilitate. And now there are like huge number of questions of like, how do you write those specs? Like, how does a human author such a description? There is no strict syntax as there used to be. When you learn a programming language, you have a grammar, you have a bunch of commands, you have a bunch of constructs that you can learn, and then you know how to combine them. And from, again, our experience, we started CodeSpeak as this kind of programming language, quote unquote, in the new era, where instead of writing code in a text file, you're writing human language in a text file. And the biggest problem we hit from the get-go was a person being asked to write down a specification of what they want, or like, how do I write a specification? Well, it's just a natural language text, like just explain in English what you want to do, but like, how do I structure it? What words do I use? Like, what is the level of abstraction I want to talk on? And these are all very valid questions. And and we saw that basically this becomes an insurmountable challenge, like this kind of blank canvas problem is really, really challenging for a lot of people. And people usually just use an agent to generate a spec.
Right.
And so our idea was initially that, a human can write down a document that captures everything the human knows and the model doesn't. Because the mechanism, how we can achieve this 10x compression is that the model can just fill in the gaps, right? So the code will be created from the spec by the model just understanding what you mean and filling in whatever you left out. So the idea was like, you only write down what model couldn't. But it turns out it's very difficult for humans to do that, at least without any like special training or preparation. So we saw people generating those specs with models, which makes no sense in our initial internal assumption. And this was a big realization. So we the initial plan was to turn CodeSpeak into this programming language by introducing some structure to natural language, like having modules and abstractions and whatnot, so that we can, again, organize complexity. But it turned out that writing down even a single file spec without any modules is not what humans are prepared to do right now. So we tried to analyze how users interact with our initial prototype and distill their challenge into what we can actually help them with. And so the current understanding of what we're building is this. We're not asking you to write down a spec as a document. We're saying this, you're already coding with agents. So you are entering prompts into your prompt window, and you're getting code back, and you're in a dialogue with an agent. And there, in your conversation with an agent, your idea of what you're building can be evolving. You can be, you can start with some basic set of requirements, then you can, for example, add some features, or you can change your mind about something and say, okay, I want it another way. I looked at how it worked and I don't like it. I changed my mind, and this set of requirements is replaced with something else. So basically, this idea of requirements is the core thing. If you think about what a spec is, essentially is a set of requirements that the author of the program has for this program. And so what we're doing now, we're looking at what you're telling the agent, and we're extracting requirements from that.
I've got the demo open on the quick start. Is that a good example to show up for what you're talking about here?
Demo.
Example in the quick start guide of the geese thing.
So unfortunately, the website has the previous version. What I'm talking about is being developed. I'm sorry about that.
No, it's fine. I wasn't aware of that.
The closest thing to what I'm describing is not the quick start guide. It's what's called takeover. So you can look on the blog, and there is the modular takeover blog post somewhere, one of the most recent ones. Okay. And that is doing something similar to what I'm saying, but in one go. What I'm describing is a little more structured, but it's the same concept. So the idea is we're looking at what you are telling the agent to do, and we're extracting requirements, not as a document, but as a set of individual statements that can change over time. So we know that, at this point, you had this set of requirements, and then you replaced requirement 3 with 3 prime that kind of refines it or changes it in some way, and so on and so forth. Does that make sense?
I think so, yes.
Okay, so you can actually still think of it as a programming language. The funny thing is that although we're changing the form factor quite a bit, the concept hasn't changed at all. We're still programming in natural language, but we just realized that it's a very declarative sort of paradigm where you deal with those individual statements of, let's talk about a program that's, a file browser, right? So my file browser has 2 panels. That's a very basic sort of umbrella requirement for a lot of stuff. Each panel displays one directory is another sort of atomic description. Cursor keys navigate between files, enter opens a directory under cursor, so on and so forth. So these are examples of very plain high-level requirements that will collectively describe a file browser. And you can be adjusting your idea. You can add new requirements. You can say okay, now I want to enter archives as well as directories. Now I want to introduce a new function. Now I want this, I had a delete function. Now I want the delete function to have a confirmation box before I delete anything, so on and so forth. So these are individual requirements that can be arranged in logical groups. They can different versions of requirements will exist in different branches or in different forks from different developers. And then when you're merging a branch, you will see how your requirements from this branch are merged into the requirements of the main, and so on and so forth. So you're basically, the representation of what the system does can be in code, but it also can be in this like requirements level, which is conceptually absolutely the same as a spec, but it's not a text document anymore. It's a more structured representation.
So there's a few things I want to jump around to here. Let me just play devil's advocate for a little bit here. You've probably seen a million times, the picture of how the customer explained the swing, how the project leader understood it, what the customer really wanted. And I guess the point I'm trying to get at here is you write out this spec, and let's say to you the spec is right, but the result you get in the end is not what you think it should be. How do you address that mismatch?
Yeah, so there are different mismatches, the different types of mismatches possible. So one type is when the intent was understood correctly by the agent, but the implementation is just buggy. So, you just say, okay, so I wanted this, talking about files, I want to open the directory under cursor, but it actually opens my home directory every time. And that's just a bug, because there was a requirement that said what should happen, and for some reason it doesn't work.
Sure.
So that's a bug. You can tell the agent that, in testing, you see that this requirement is not satisfied and it needs to be fixed. And it's a separate story, by the way. Requirements are incredibly useful for deriving test suites because they are individual statements. So for an isolated statement, you can devise a bunch of test cases, and you can probably even run them automatically and check if the requirement is satisfied. But assuming you haven't done that and you are doing manual testing, you can say, okay, yeah, I see. So there's a bug. Like, it's obviously a bug. It needs to be fixed, and the agent will be fixing that.
Sure.
There's another option where your requirements were not really specifying something, and there is a different interpretation that the model took. So you wanted, I don't know, you wanted a TUI, and it built you a web UI for your file browser. You're like, oh, I forgot to tell you that I actually meant a TUI. So that's completely in-spec change. So you're adding another requirement that you want this to be a TUI application. And this is like completely fine. You may need to rewrite a lot of may need to regenerate a lot of code because of it. But the important thing is you can actually try this experiment. It will only take you half an hour. You can try to build like a basic file browser in web UI and then tell it to rewrite to TUI and see how many features it will forget on the way. It will be quite interesting.
Right, this because, is like a context window problem, is it?
There are multiple things. So if you're doing it in the same session, it will be a context window problem, which is real. If you're opening a new session and doing that, it's just that all the features are not listed anywhere. They're not in context at all. And they will be like inferred, reverse engineered from the code or from whatever MD files you preserved, like plans or whatever you let the model read. But like practically you can try this. And it's often difficult to retain all the features. And this is a very extreme case, of course. But a more sort of day-to-day thing is I'm working on this project. It's a big one. And I open a new session and I describe a new feature I want to build. And it gets built. But on the way, 3 more features that existed already and worked fine are broken because the agent didn't realize that they existed while it was building the new one. And this is where requirements really help. If we can preserve the entire set of requirements for this project that are actual at this point in history, and we can add them to the agent's context, and we right now do it through a simple plugin to Claude Code, just a hook that reminds it of all the relevant requirements. It's, now it knows that the features existed, and it won't be breaking them so easily. And if you have a good test set derived from requirements, it's even better. But to prevent even like the silliest mistakes, it really helps to surface all the requirements relevant at this point before it starts generating code that's just forgetting things.
The other thing I wanted to say is you've mentioned that the amount that you write yourself is 5 to 10 times less, but what about the time to create that document, that time to create those specs? Because it's one thing if it's less to ultimately write, but if it takes you 10 times as long, you're basically at the starting point you're already at.
That's fair, yeah. And I think this is the problem we hit with the initial version when we actually asked people to write like proper documents. And this was a big revelation for us that, writing something from top to bottom is very difficult. But if you go with agentic coding approach where you write short prompts and you refine your understanding and you like prototype and iterate very quickly, you end up with a session, like the entire conversation with an agent that contains all the requirements. It's like it's not a document. It's very messy. It's not something you want to show your colleague to explain to them what you're doing. But we can extract the document from the session. It's contained there. It's just like very cryptically encoded. And this is what we do. So basically, we'll let you as a human follow your own thought process in a dialogue with an agent, but then we can extract a document from that. Like not even like we can turn it into a document as well, but we can extract something better than a document. Let's not dive into this right away.
Okay, so you can sort of iteratively build up the requirements, right? Like, starting with a blank sheet is always this scary, difficult proposal to have. Even if you have an idea of a complex system you want to build, that idea of where do I actually start breaking down this problem, that can be an immediate blocker for even the most experienced of developers.
Yeah, and it's also a lot of us, even like very experienced people, may need this exploration phase or ideation phase where I have a sort of a feeling, a hunch for what I want to build, but I need to poke around in what I already have. I need to try this and that and see what works better. And this is a very valid process. Like this is the creative process of a developer who is like trying to figure out the specifics of what they want to build. And it's incredibly helpful to use an agent to prototype as you go. So one thing you can sort of try to keep it all in your mind and imagine different versions and think them through. Some people are very good at that. For some people, it's just a very sort of difficult chore. And I think for most of us, it is kind of a chore. And it's a lot easier for most people to prototype it and see the prototype and see what you don't like about the prototype and fix the prototype and accumulate your understanding through this iterative process. And then you get this through this prototyping. What you get is just code. And usually it's not very pretty code because you were trying things out and there was like lots of dangling ends and whatever. But now on top of the code that you might not really care about, you already have this collection of requirements that you've developed through this process. And that collection of requirements is a good source of truth for what you want to do. And depending on how careful you were while working on this, you may even want to keep the code, which is fine. Like depending on how vague your idea was initially, you may have a pretty good implementation at the end. You don't have to throw it away. But importantly, the whole point of like raising the level of abstraction is to put the source of truth in the human language. And this conversation with an agent that ended up in a version that you're satisfied with, it contains all this truth in the most compact way, in the way that you were thinking about it, right? So it's in human words, it's not in code. So it's higher level of abstraction already. the thing that we need to do is to extract it, make sure that when you change your mind, we took that into account and we don't use like stale descriptions and things you don't really want anymore.
Right.
And just put this together, and there you have this source of truth kind of document that already generated an implementation that you're satisfied with.
Mm-hmm. So what is the, I guess, current state of things, and what are the sort of areas where you think things can be improved with how it currently functions?
Yeah, so if you take what we have on our website right now, this will be CodeSpeak Takeover. So the thing that's on the website is you can just install a Python package with CodeSpeak, and it can do a bunch of things from the old version, but it also has this takeover command that's kind of close to what I'm describing. And that will be like the first iteration of this idea. It can read your code and your sessions, and it will show you, first of all, the module structure of your project. And then for each module, you can extract the requirements from your sessions. And that those requirements will be just saved as an empty file with individual requirements listed more or less structurally, feature by feature. So this is a very early prototype. It's kind of slow. It's not like the representation is not very structural. It's a little expensive, so it's kind of a super early thing that we showed a bunch of people. We got their feedback. And now we're building a much more sort of thought out version of that that will not require waiting so long. It will not require so many tokens spent. But the overall idea is the same. We are looking at what you were talking about with your agent, and also looking at what other people in your team were talking about their agents, and we're putting this all together to have a complete picture of what the requirements are in your project.
I think it's definitely a neat idea, because there's always been this idea of, as we said, like bringing the developer to a higher and higher level. And there's not really a higher level that a human, as we currently are, can really interact with a system than natural language, where you can just describe what it is you want to build and have that be built. I'm very curious to see sort of where this can go as these models can get more and more powerful over the years. Because we can look at what it can do today, and that I'm sure it can generate like reasonable projects now, but that's with the models we have. We don't really know how much more powerful we can get in the current path that things are going, and where that really goes. So yes.
Yeah, so it's a very interesting kind of question of what models getting better can affect in this picture. And if you think about it, like right now, we have the kind of models that can compress, let's say, compress your code 10x.
Sure.
Like you can describe what you want in 10x fewer characters than the actual code you generate. The smarter the model, the more things are obvious to it. So ideally, the smartest useful models we might have will be so smart that I will not need to explain anything to it that is already obvious to me. Right? So if I'm explaining this to a competent human engineer, I'll be transmitting some information. Like, again, like my intent is only in my head right now. I need to communicate it. But the smartest model will be the one that doesn't need things being explained if they are obvious to a competent human engineer.
Right. You wouldn't need to explain to a senior engineer, hey, use this obvious function to do this thing. Don't go and invent some new way to do it. Use the standard way.
Yeah, and a bunch of other things. Like you need to take into account a lot of concerns. Like if we're building this high load system, take into account the scalability concerns. If you're accessing some REST API think about exponential backoff and what you do on 49. And such things are kind of obvious to engineers. Some of them are already obvious to frontier models. Like Claude will generate some like common sense things that an engineer will. And they will get better at that. They will get logging right. They will get exception handling right. These days, sometimes they do already. Sometimes what they should do is say like, oh, your project hasn't been set up yet for observability, but we are building something where observability is really needed. Like, should we actually talk about what we want in terms of observability? This is what a senior developer would do. Or, I mean, if they're not very talkative, they might just go off and set up observability the way they prefer. And models sometimes do that as well. But, so this is the level of questions that's kind of relevant in terms of, like, this is an important decision. We need to make it somehow. And this needs to be explicit by the nature of the system. And some things are like, if I'm talking about observability to a person who's built observable systems before, I'm not explaining what it is and like what basic expectations I have of an observable system.
So as it currently stands, you still need to sort of babysit the system more than you would like to in like a world where this is kind of a norm of the way that you would write code.
Yeah, and you will see people who think that it all has already happened, and in their use cases they don't have to babysit it at all. I'm not the person. I have to babysit them, maybe because of the nature of the systems I build, maybe because other people have infinitely better skills at using agents than I do. I don't know, but this is what I'm saying is there is the scale of how smart a model is. And the scale characterizes exactly that, like how much you need to babysit it in some way, like how much you need to correct its mistakes where mistakes were detectable, knowing the requirements you gave it, how much you need to guide it through complicated decisions, how much it will do silly things like, I don't know, duplicate code or forget about existing features and so on and so forth.
Okay. There was a few things sort of semi-related to this I did want to sort of get to. You did mention price in there, and I did kind of want to talk about the sort of direction that token pricing has recently been going. You might have seen GitHub. They sort of they took the Band-Aid off that needed to happen at some point.
Yeah.
What do you see sort of happening in this space? And with what you're building here, it's obviously going to be very, very affected by how this ultimately goes. Right now, companies like OpenAI are not profitable at all. And at some point, that money dries up and they have to say, we need to make money now. And where does that really put like things like this that you're building? Do you see sort of more of a move to, things like with the what was it, RTX Spark, the thing NVIDIA unveiled recently, the AI laptop things? Do you see more movement towards these powerful local models, or what do you really see happening here from your perspective?
Okay, there are many questions here.
Yes.
So it's the kind of easier one is on local models. So I'm super enthusiastic about this kind of on-device inference stuff, but I also understand that if data centers have shortages of chips, consumer devices absolutely have shortages of chips, right? So the chips of the power needed to deliver the quality of frontier models are like not going to be available to me. They are somewhat available to me, but they're like expensive as hell, and I have to wait a very long time to get one, or like even not one. I need 8 to run anything, right? So I don't think it's reasonable to expect, consumer hardware to be that good.
Sure.
Like, it can run something, but it's not going to run good LLMs.
Right.
And right now on some like really beefy Macs, you can run like a larger open source model. It's going to be slow as hell, and its quality is kind of not great. It's not the biggest open source model either. And that's the situation. And you need to realize that this is not very temporary, because right now the scaling of the quality of the models we're using is based on the amount of compute you throw at them. And data centers get compute in bulk, get electricity in bulk, get cooling in bulk. So it's all like they have economies of scale. And at home, you don't have the economies of scale at all. So it's, if you could run those frontier models at home, they would be prohibitively expensive.
Right.
Right, because like everything, even as a company, as a business, you might consider, like, should I rent a couple of GPUs and host my own open source models? And the answer is you absolutely can if you have enough load. Like, if you can use your GPUs 24/7, then yeah, it's going to pay off. It's going to be like some engineering involved and whatnot, but it's going to pay off. But if you don't have enough users or enough use cases to load your GPUs constantly, don't rent a GPU. It's going to be incredibly expensive. Like, use Open Router or whatever, because yeah, they have the load and they have the economies of scale there. So you need to keep this arithmetic in mind. And it's like, you can run an open source model like very cheaply per token if you produce tokens all the time.
Right.
Yeah. So that's excuse me. That's kind of one aspect of that. But also, like, in terms of how this like current situation of subsidized tokens is affecting the industry, the one thing is, I don't really know how much a token is today.
Right.
Because the subscriptions are subsidized. Also, I'm not sure if APIs are not more expensive to subsidize the subscriptions. I have no idea. Right. So they're like, I have no idea what my unit economics look like right now, and that's a genuine challenge. What I'm trying to go by is just calculations of what it would cost me to run a big open source model, just renting hardware, and this kind of, you can calculate how much it is. And open source models are like half a year to a year behind the frontier, but you can kind of extrapolate that. They will probably catch up and so on.
Right.
So there, like, you can get this idea of how expensive it's going to be. And it doesn't look terrible right now, but you're definitely not burning tokens without thinking anymore, like you used to. But no, not anymore. And as you said, like GitHub Copilot not accepting new paid users is an interesting development. I didn't expect them to do it. And incidentally, like right now, we actually need a few Copilot subscriptions because we want to support Copilot conversations in our product, and we can get one. Subscriptions are not available.
Right.
Yeah, and this is probably like a passing moment.
Sure. It would be a bizarre business model to just say no more customers.
Right, of course. Yeah, so they just need time to regroup and whatnot. It's going to be fine. But yeah, the truth is, we got to a point where the users know how to consume like incredible amounts of tokens. Not all of it very rationally, like it's not optimized on the user end, but we got to a point where, okay, now everybody knows how to spend tokens. And this is an important stepping stone, because before we just didn't know what tokens were good for. Now we do, good, but we'll spend some money on that, like we as an industry. we spend some money on that, and then now we need to count the money. Yeah, that's real. And the thing is, I don't really know how expensive it is, but I suspect that it's still it makes economic sense to use AI. Like from very many signals.
That's kind of like where I was leading us towards, right? Like this is a common discussion point that comes up. Not knowing how much it costs, we don't really know what the price point is exactly at. So the question then becomes, is the approach we are taking, is it actually economically viable in a world where we're not seeing subsidized tokens, right? Like that's the big question here. If you're paying more for tokens than you would pay for equivalent developer time as a salary, does that make sense?
Sure. Yeah, so I guess I don't have the ultimate answer here, especially for like specifically today's situation, because the situation will change in 3 weeks, and I don't even know when this podcast goes live. So the thing is, there definitely are useful models that are economically viable. I don't know if the most powerful models that we have today are already economically viable, but I suspect that they can be optimized and made cheaper, probably. But definitely, we already have some models that are already useful, maybe not as impressive, but definitely useful and viable 100% at the same time. So it's not like, this entire AI thing is going away. No. The question is is the Fable class model economically viable right now? Like, can a software developer team use this kind of model and be really profitable, be better than just using humans? And it's not a calculation of just salary against tokens. It's also delivery time. If you get something for 3 times more expensive, but it ships 10 times faster, maybe it's an incredible opportunity that makes your business better. I don't know. Right. It depends on the business very much. Yeah, but definitely we don't know the current situation. We can't tell whether this business is basically borrowing its productivity from the investors of whoever is subsidizing the tokens. And this productivity will not be viable tomorrow when tokens have actual prices, or maybe they're already fine and all the prices will check out and everything will be okay. But the question is real, and I'm 100% sure that there are people out there who are exceeding any reasonable budget and in real money spent on what they're doing.
Go on Twitter for 5 minutes and you'll find go on LinkedIn for 5 minutes, you'll find these people.
Yeah, and even some people really like to inflate their numbers because it's nice to brag on the internet. But even without completely outlier cases, there are quite a few people who set up really token hungry workflows that are yielding them good results, but they may not be economically viable right now. And at the same time, there are people who plausibly are absolutely fine and now they pay, I don't know, $200 a month for their subscription, and actually they are spending $1,000, but that $1,000 actually pays off.
Right. So you've obviously got a long. When did Kotlin, you said, was 2010? Yes.
Yes.
How long have you been an engineer for?
I started my first real job in 2005.
Okay.
So it's been 20-something years.
So you're someone who's obviously been doing this for a long time now. When did you think that there was something there with these AI tools, right? Because early on, we saw them, the results back in 2021, whatever year it was, things were moving, but they weren't exactly viable for any real use case. When were you kind of on board then and saw where things were going, or did it take you a bit to sort of get interested?
Okay, so let me remember. So 2022 was the year of like the GPT moment, right?
Something like that, yeah.
I think so. Yeah. So I remember talking to my like ML engineer friends about it when it came out, and the code it wrote wasn't super impressive, but it was like, okay, it can really do things. It's like not smarter than me by any means, but yeah, it can do things. And I remember then I was super skeptical about all those conversations of like models will code on their own, like you won't need to supervise them. And interestingly, I'm almost equally skeptical nowadays. My arguments are slightly different because then I thought that the human language was not precise enough and like you will get lost in little inconsistencies and misinterpretations and all that. But for a lot of applications, it doesn't seem to be a problem at all. Like maybe if you're building something like that relies on a lot of super precise computations, maybe there you will hit those problems more. But for normal applications, what we usually build for a lot of industries, like in very different kinds of things, small systems, big systems, from video games to like high load data processing pipelines, those things, natural language seems to be good enough.
So you're talking more about still, like the highly complex scientific modeling software, things like that, where being very particular about what it is doing is incredibly important to its function.
I suspect, yeah. So you will need to be super careful expressing your like what kind of formula you actually want to be calculated in what way. And there, maybe a programming language is just more efficient at expressing that altogether. And it will also give you like more static checking, so you make fewer mistakes and you find them quicker and so on and so forth. So if you need a huge level of control over tiny details,
right,
a programming language is just more efficient than human language, and we've known this for a long time, actually.
Right. You're launching rockets, for example. you probably want good control over that.
Yeah, so I think in launching rockets and in generally in writing, incidentally, we also use control systems as a class of systems. So in control systems, you want a lot of control.
Right.
Yeah, there's also like there's some work on writing control systems in something that looks like natural language but isn't, and that's a separate question. But basically, when we talk about most applications we write, like 95% of all the code in those applications don't require this level of control.
Right.
Some control is needed. Like we need to be sure that it's actually doing what it did before, and like we need to test a lot, and we need to actually spell out what we want. But we don't need like super fine-grained control. We don't need to go down to the programming language or down to the metal for most things. And yeah, so I guess my concerns changed. But, and this idea of engineering being at the center of it wasn't what I was thinking in 2022. But then, I just talked to a bunch of people, and we were like, I was hashing out my arguments, and there were incredible amount of super optimistic people who were thinking about like fast takeoff next year and things like that. And then, when we saw tool calling. Initially, I think it was 23. I don't remember exactly. I was like, oh, cool. This will be able to do things like search the internet for me and do other things tomorrow. And then it didn't come for another year or maybe longer. And I was like super bummed about that. So there was a moment when I was super optimistic about something that just took time to build. And it was actually a big realization for me, I think around year 24, where I realized that many things that are thinkable and that are easy to imagine and are absolutely doable are not happening very quickly because they're hard to build. And there were like blog posts on the internet about like this and that thing happening, like agents were a concept long before they were practically implemented like in a usable way. And I was like, oh, right. So if I can imagine it like sitting in my chair in a minute, it doesn't mean it will be implemented in a minute. It doesn't mean it will be implemented in a month.
Well, if you want to go back even further, a lot of the math behind how these models work, we've understood since like the 80s. It's just we didn't really have compute till very recently. I guess,
like on some level, yes, but I think the attention paper from 2017.
Sure, yeah.
Was not something known in the
no,
80s,
no,
right?
no.
So there were like major breakthroughs there.
Yeah.
But yeah, so like fundamentals of neural networks were known.
Yeah. Sorry, I sidetracked you there.
Yeah, so I guess a big realization for me was that, you know, even within the industry where there are a lot of experts specifically like working with code, I was imagining that, you know, by year 24, we'll definitely have incredibly good RAG on code and like even more sophisticated things for code search with like semantics from LLMs understanding code. Well, it's not there yet. I mean, there's progress. Like people are building much better systems nowadays, but it's not like Claude Code is using an incredibly sophisticated RAG that's much better than grep. No, Claude Code is using grep, which is like a mind-blowing thing for me, like as a person who worked alongside people who built IDs with incredibly sophisticated indexing algorithms and all that.
Mm-hmm.
You know, the algorithms are still there. Yeah, but I mean, agents kind of, first of all, it's incredible that agents do this well without really using anything beyond grep.
Mm-hmm.
And to be fair, some agents have some indexing for the code. But also, you know, it's actually pretty hard to build a good code search thing for like generically for like arbitrary code bases. And it's not there yet. It's being built, as far as I understand. Like everybody who owns you know, any code comprehension system, any ID or you know, code hosting, they are all building those systems, and they have some versions, but they will be better over time, and they're not fully there yet.
Mm-hmm. So it sounds like you are very, at least for now, optimistic on where things are going.
Generally, I mean, I don't know what qualifies as optimistic. Okay. I think there is a lot of progress ahead of us. I'm definitely not as optimistic as some people. You know, there is this phenomenon. I live in London.
Okay.
And when I meet someone who's just come from San Francisco, they are like from a different universe, which is kind of interesting. So I'm like not following everything on the internet because I'm busy building the product. Thank you. So, you know, I'm not always aware of what people are like obsessing about on the internet. But it turns out, like when someone travels to the valley or just, you know, visits from SF, it looks like there is a completely different like bubble of hype over there, and people are thinking in super high level concepts, and as if they are already happening, which is, I mean, things are being built to make these concepts possible, but we're not there yet, and by far. You know, people are talking about like one-man show billion-dollar companies. Come on, we're not there yet. It may be possible someday. To be fair, I don't believe it will be possible for a long time. It will probably be possible for a short period of time when some people will have this unfair advantage of having mastered something.
Yeah, it's like when a lot of people have access, you can't all be billion-dollar one-man shows. Someone has to actually buy the product.
Yeah, and I mean, yeah, the idea is that this kind of one-man show will be also selling the product on their own and building it and doing everything.
Yeah.
Which, I mean, you can automate some things, but $1 billion is a lot of money. So, and I'm not saying that we will not see a single person like that, but we will not see a huge number of them for a long time. it will be a short period of time when this is possible, unless our money gets devalued so much that $1 billion is not much money anymore.
Let's. Sure. Okay. Yeah. If we're gonna do that, then yeah. What? Yeah. Not exactly a fair way to solve it, but sure.
Right. Yeah. So, and people advocating for this kind of concept, some of them actually have the power to do this to the currency, or are approaching the position of having that power. So that's not completely out of the question. Yeah. So some things are sort of, as ideas, very graspable. And I think a lot of people sort of blow out of proportion how real they are already. And, for example, like my favorite learning from a few months ago, I think it was in January when I was looking through reports on adoption of different coding agents across the industry. And Claude Code was all the rage, and, people have just discovered it. And so many people were like, everybody's using Claude Code. And I was reading the reports, and the number one AI coding tool in January was GitHub Copilot. And by a large margin.
I assume there's someone who's a web dev who's watching this who's going to understand exactly what I'm going to say here. I remember early React, early all of these popular frameworks now, and people are like, oh my god, this framework's amazing. Every other week it was some new framework, and then you look up what the most popular library that people are using, and it's jQuery.
Right. Yes. Yeah, and it's, so there is this sort of hype that makes you think that everything's moving so fast.
Yeah, exactly. Yeah.
But realistically, I'm talking to my friends who work for leading companies in the industry, and they tell me how they got access to something as basic as Claude Code at work last month. And this is real. This is not something exceptional, because a lot of big companies spent a lot of time making sure that this is not compromising their business, and just negotiating their deals and whatnot, and trying to build something in-house and a lot of stuff like that. So this concept of everybody on Twitter is talking about something is very different from the concept of the industry has changed. The industry is starting to adopt those cutting-edge technologies. The technologies look really cool, but we're not there yet. We have some time before this completely happens.
Right. You can always point to the startups who are doing crazy things, because that's what startups do. But your HPs and your, I don't know, actually Meta's a bad example. Meta probably, but
Meta is trying to be at the forefront, but they also they're not adopting everything the minute, or
right.
They weren't 6 months ago.
But pick some boring generic software firm, right? They're not moving at the same pace as some 3-guy startup out of the garage.
True, yeah, but also not even a boring generic. Take someone as hip and cool as I don't know, Shopify.
Sure. Yeah.
People like that, and at the moment where everybody was Cursor was the biggest thing, and everybody thought that everybody was using Cursor, they were trying to implement these things. Those companies were trying to implement Cursor, and a lot of their engineers just weren't using it. And this is normal. People don't adopt new tools very quickly. It takes them time to learn. They don't find them useful in their specific use cases. It's one thing to say the founder of this very famous scale-up or large unicorn startup is super optimistic about this tool. It's not the same as every engineer actually uses it every day.
Right.
It's the founder's role is to lead. And if they started leading this a week ago, nothing has happened yet.
Right. There can be a lot of we're doing a big investment into this, but have you actually convinced the people who actually who's supposed to be using the tool to actually adopt it? And not even just convince them. have you given them? Is there a reason why they would want it, right? Like, have they been shown why it might even be useful in their workflow? And you made a good point there. Like, a lot of people haven't even played with these tools yet, right? We've been talking about how people are learning how tokens work, learning how to use tokens. But if you've just never interacted with these, you've just been enjoying your developer job the past 4 or 5 years, you've not really been paying attention to what's happening, but you've not really experimented with these tools. You're at that same starting point that people were at 5 years ago.
True, yeah, and also like as an engineer working at a like real company with like doing real business, you have a lot of responsibilities. And somebody hands you this toy. Yeah, great. Like, I have a bunch of things I promised to do this week. Okay, so like, yeah, this toy looks kind of cool, but I don't really know how to use it effectively. It will take me time to ramp up. And maybe like in a month from now, I'm super productive with it and it's incredible. But today, I have my obligations. Like, I have to deliver the things I promised to, and I'm not going to spend another hour learning that toy. And like, for some people, it's easier and they will do it over the weekend and whatnot. For some people, it just takes longer. And it's also another thing I noticed with agents specifically. Some people intuitively work a lot more productively with agents without learning as much as some other people. So, and those people are more vocal because they're more happy with their results. And they make it look like it's super intuitive and you don't really need to learn. But you do need to learn. These are tools. These are complicated tools that exhibit very complicated behaviors. And to really master those tools, most people need to learn. And we need to allow them the time to learn and better actually provide them some learning materials, which are not very systematic at the moment. So, but some people have this natural intuition and their results are incredible from the get-go, either because they just are lucky and like their heads work like that, or because they were so excited in the beginning that they spent those hundreds of hours in a couple of weeks and just got this mastery out of that. Either way, it doesn't mean everybody will do the same.
What do you think it is that cause some people to sort of pick this up a lot quicker? Do you think it is this people who are more used to explaining what they're doing? Like, do you have any sort of thoughts on why some people sort of pick it up so quickly?
Well, I have some observations, but I'm not like super sure about. So one thing that I've heard from a few people who are pretty productive with their agents is that what helps them is this kind of management skills they have. So they know how to formulate a task in a way that they will be able to check where the task has been completed correctly. And that's ingrained in their, like, it's either people who work with students a lot or just, managers who delegate a lot. They will, at least, those of them who are successful with agents attribute that to this skill. I'm not sure, whether this is just a confirmation bias or not, because people like to sort of devise theories for why things work out for them. So that's one thing. Another observation that I have is then when I ask people who are like super productive or like consider themselves super productive with agents to sort of help someone else to become productive, they kind of struggle to explain what they need to do, or what they're doing wrong. So it looks like there is this sort of neural network in their minds that kind of connected correctly, and it works for them, but they don't always have a very clear concept of what they need to tell another person for them to learn, which is generally not uncommon with a lot of skills. Like a lot of things, a person who's incredibly good at math is not always a very good math teacher.
Yep, I've definitely had those. There was a couple of professors I had who were definitely like that.
Yeah, and it's very understandable. Like empathetically, you can easily understand. How do you explain to someone how to walk?
Right.
You learned that before you've reflected very much, right? So you just walk. And you can, and we have expressions of like put one foot in front of the other, which we actually don't do. Like not literally, like we don't put a foot in front of the other foot. We put it a little bit to the side.
Right. Yeah. Okay. Yeah. That's.
So what I'm saying here is that there is something you can be incredibly good at, that you may not have a very good concept of, like how you do it. You just do it.
It's something you maybe not intuitively understand, but for some things that's definitely true. You speak to anyone who's really good at the sport, for example, but you have this understanding of it, but you just don't know how to explain it to anyone, simply put.
True. Yeah. And I mean, I have this example that I give a lot when talking about this kind of implicit learning, where you know what a slack line is, right? So when you have this kind of wide strap between two poles, and you can walk that. Yeah. And so a couple of friends of mine were like very much into slackline walking, and they invited me to a park one day when they had a slackline with them, and they're like, "Do you want to try?" And I'm like, "Sure, let me try." And I put my foot on the line, and it's absolutely obvious that you can't even stand on it, let alone walk on it. Like, it's impossible. And they were like, just try 10 times. And after trying 10 times, I could stand on it. And then after a time, I could stand for longer, and then I could make a step. The thing is, like, I just kept trying. The thing is, after I learned how to stand on it, I didn't understand anything, like nothing at all. Like, I have no mental idea of how to stand on a slackline. My body figured it out. It never told me how. Like, and this is just a skill you learn, and a lot of other things are this kind of skills that you learn, and you don't realize that you have the skill as a separate thing. You don't realize how the skill works, and you can't explain to anyone how to do this. Like, you can't just through words give them the skill.
Well, a skill that most people probably have that's a bit more common than slacklining, riding a bike. You can teach it, like, you might be able to, like, put someone on a bike and, like, you've got, like, a rough idea of how this works, but the second you let them go, you have no idea what to say to them to make them understand. Like, you naturally work out that to turn the bike, you lean it. But this is not something that you were ever probably told, and it's probably not something you even think about when you're actually doing it.
Yeah, and when we talk about agents in particular, there are so many little things that may matter. And, because the model, like every character that you type in is an input, right? So they all affect things, but potentially. And how you, like, in what order you explain things and what specific words you're using, it all may matter and may not, or it may not, right? So you may have, like, your own internal rituals as a user, like, that you learn. You get the habit of using something, maybe because you just like it this way, or maybe because it's really helping, or maybe because something else is helping and you don't realize it, and you just incidentally use both, and it's hard to reflect on it. It, like, requires a lot of measurements to be sure what's actually useful.
We disconnected just very briefly there. I heard the rest of what you're saying, but it disconnected just slightly. So I think we're good now? Yeah? Okay, cool. I don't know if it even disconnected on your end. I probably didn't even... It was such a brief thing, it didn't even... Yeah. Okay, we've sort of brought up how you've said that this work on CodeSpeak, this work on sort of designing a system is sort of a extension of what you've done in the past with Kotlin. I did want to sort of touch on Kotlin a little bit. I guess, how did that all get started, and what were you trying to do that was different than just, going using Java?
Fair, yeah. So important context is that it was 2010.
Right.
So in 2010, the situation in the Java community was a little bit tense because the last major version of Java had been released in 2004. It was Java 5.
Was it? Wait,
And,
was it that bad back then?
Yeah, it was like, and there were updates. There was Java 6 and Java 7, but those weren't really significant. Like they did change much.
Yeah.
And it was, it was a consequence of a bunch of things happening at Oracle. But in any case, so Java was considered stagnating widely in the community. A lot of people were really mad because just next door, C# was progressing quite a lot. And C# had all the nice features that Java didn't have. And so the community was kind of tense around that, and a lot of people were grumpy. And this is why people at JetBrains saw an opportunity here. Like, yeah, so Java is not progressing that well. We are positioned uniquely, like we have programming language expertise, we have the user base, we are very well known in the Java community. We can make a language that will make it so much better for so many more people. And that was the idea at JetBrains before I joined. So basically, the guys there were just like asking themselves the question of, what else can we do for developers? We already have great IDEs, like a continuous integration server and a bunch of other things. But like, what else can we do? And the answer for the Java community was a better language, or at least they believed that it was relevant. And this is where it so happened that we met with some people from JetBrains. And they quickly persuaded me that it was a good idea to start a new language. Like generally, just to be clear, generally, creating a new programming language is a very bad idea on average. Like most of the time, it's a completely like dead in the water kind of idea. But sometimes, not very often, you have like a considerably better shot than an average programming language creator. And they convinced me that it was that kind of moment because of the position of JetBrains, because of the market situation. And I was 26, okay? So I was not risking very much. I was like, okay, so comparing this to any other opportunity I might have right now, this is the craziest and the best. So I'm taking it, let's try to do it. Also helps to be young, to be really, really confident and being able to create things. Yeah, so I'm incredibly grateful to the guys who actually trusted me with this. Yeah, so this was the rationale, and it actually turned out to be like very, very spot on in terms of the market. And it turned out that like we were not thinking of Android back then. We were thinking about Java server side, basically. And then it turned out that Android was an even stronger, had an even stronger pain of the same nature, because they were like, because of some of the infrastructure things, they had stuck with Java 5 or 6 even longer.
Right, with this being 2010, this was still fairly early on into like smartphone adoption.
Right, so when we started, Android wasn't like, we were not even thinking of it, of course. But like a few years in, Android was becoming a thing, and I was vaguely aware that it uses Java, but it turned out that it was a very rapidly growing market with a huge pain, even bigger pain than server side, because it was very hard for Google to to upgrade the virtual machine on all the phones. If you have like hundreds of millions and billions of devices in people's pockets, you don't easily deliver an update to every one of them. So, even if you develop a better version of your virtual machine, it just doesn't hit the users very soon. So having something that worked with the previous version with Java 6 was crucial, and Kotlin was that. Like, was nicer language, still working on the old virtual machines. So in a nutshell, this is how it played out. So both the Java server side and Android markets actually worked out. Android was just much more receptive because of the stronger pain, and of course because of support from Google. But even the Java bet also paid off.
Okay. Yeah. I've not really worked with Kotlin before. I've done plenty of Java. I don't like Java. I've done plenty of Java stuff.
Java is a great language.
Yeah, it's a great language. Yeah. Sure, we'll go with that.
No, to be fair, so Java in its day was a completely revolutionary awesome
Sure, yeah,
language,
okay,
and,
fine. I'll give you that.
no question about that. So for one thing, then Java had like a long period of not being really up to date and whatnot. It's getting much better now. But so the idea of Kotlin was to sort of upgrade all the fundamental concepts that were already there, just make them more modern, implement all the nice ideas that we've accumulated over the years. And it was basically introducing a lot of the goodies of functional programming without being super academic or like requiring people to relearn a lot of things. It worked. It's raising the level of abstraction. We introduced some things that were absolutely known. We were trying to invent nothing. We invented a little bit of stuff because sometimes fitting things together requires coming up with new things. Sure. But generally, we were using existing concepts known forever. But altogether, this was another step of taking academic ideas that were not computationally viable in the 80s and implementing them on the hardware of the 2010s.
Right.
And so we raised the level of abstraction quite a lot, and we also added a bunch of smart checks that catch your errors early on, which a lot of people really like. So nullable types, big thing there, but there's a bunch more. And that was a relatively small but meaningful step in terms of raising level of abstraction. And in this sense, CodeSpeak is a step further, like raising it further, but this step is much bigger.
I think everything you described here honestly sounds really, really interesting. I'm so curious to see where this all goes, right? Like as I said, I don't know where the market's gonna go. I think, as you said, like this tech's not going away, right? Like we can talk about AI bubble, and there's definitely a bubble. There's companies who are trying to inject this into every little you think back to like pets.com, right? Like sticking .com. There was a period there where if a company put AI in their earnings call, their stock price went up, right? Like there was just ludicrous things that had been happening. But I think there was a bubble, and we're not necessarily seeing a burst. We're seeing more of a deflation where we're seeing this more practical use cases, more practical usage becoming the norm that we're seeing. Now that people are starting to understand what this tech can do, we're moving more out of that experimental stage where people are just throwing every possible idea out there to this is what we can actually do with this tech, right? Like this is how we can actually integrate it into real, actual businesses.
Yeah, it's interesting that you mentioned deflation, because I don't even know if that is happening, to be honest. I mean, it might. It's up to debate, but it may be like the bubble itself. The bubble situation is when the expectations of investors are so unrealistic that they can get sharply corrected down.
Sure.
And this is how like money evaporates from the market, right? So, and here we might have this situation where the expectations of investors are getting more realistic, but we also might have the situation where the reality is slightly catching up with the high expectations, and they definitely don't match yet by far. But I don't even know which way it's moving because it's pretty hard to calculate.
Right.
But we definitely, like quite a few promises, not the biggest ones, but quite a few promises have been validated. Like we really have realistic material improvements coming from AI already. And this was the entire promise of the initial bubble. Like this is why people were so optimistic, because this technology was supposed to improve productivity so much. And we see places where it does improve productivity. It doesn't bring like revenue or earnings to the people who are using it as much as we expected, because we expect everything to happen instantaneously, and actually dissipating technology takes time. But a lot of things have been kind of confirmed. A lot of things still look fishy as hell, and companies inflating each other's valuations through those like spaghetti diagrams.
Right. Yeah. Just circular
money.
It's
not great.
Yeah.
Yeah. So all these things are definitely not great. But in terms of the basic idea of expectations versus reality, the gap may be smaller today than it was a year ago, but I don't know whether it's deflation or just the expectations being more realistic than some people thought.
Okay, no, that's fair. That's fair. I can see what you're saying there. I kind of use deflation as just like just a general term, meaning that the I don't think it's not gonna just burst, right? Like we're not gonna see I don't think. Sure. Maybe I'm wrong. Who knows? Maybe I wake up tomorrow and OpenAI just says, you know what? The investors gave up. There's no money left. I don't know. Could happen. But I don't think it's gonna happen, right? I don't think we're seeing another situation where Nvidia's now at the top. Nvidia's not going to lose like 90% of their value overnight. We're not seeing a .com situation happen. I don't think.
I don't think so. Yeah.
And if it does, I think it'll be a lot more gradual, right? Like you'll see a drop, but it's not going to be it'll be investor money dries up and things have to start become profitable again. It's not going to be just crash into the ground.
Yeah, so I'm not an economist.
I'm not. I'm just throwing things out there.
My understanding of this is that like it's still any really heated market situation can burst in the sense that investors panic and just pull their money. And this doesn't mean that like anything material happened outside of the stock exchange, but the stock exchanges has very material effects and things.
Sure.
So it doesn't mean that whatever value was in NVIDIA, like material value, like the actual chips, the actual technology, the actual knowledge that they had, it doesn't evaporate overnight.
Right. Well, the difference now and back with the .com bubble, NVIDIA's, if AI disappeared tomorrow, NVIDIA's still a real company, right? Like we still need GPUs.
Well, I'm not sure if we need those GPUs if there is no AI on the planet.
Okay, but like the fundamental concept, like NVIDIA is they're a real company, right? Like they actually make a real product.
Yeah, that's true.
There was a lot of the .com companies where they were not real.
Yeah, but to be fair, like NVIDIA is in the position of like Cisco in the .com bubble. Yeah. Right. So and Cisco was building actual stuff. So it's like whatever .ai will be in the position of Pets.com.
So
but like I guess circling back to what it all means and like why we are still trying to improve an already so optimistic technology. We have agents. Agents are great, aren't they? But at CodeSpeak, we're trying to do even better. Like, why would we? Being so optimistic about everything. I guess an important point to make here is that so right now, having all this power comes with some downsides, like material downsides, when people can generate a lot of stuff and other people don't have the capacity to look through this stuff. Both in social media, like you can generate tons and tons of content that nobody has the capacity to either just read, or moderate. You need machines to moderate the machine-generated content, and there can be like so much created in so little time. Right, and the same thing I think we're seeing in like the open source community when people can generate so much code and submit them, submit those pull requests to so many repos, the maintainers just can't really keep up with that. Like it's infeasible to do it however you slice it, right? And so this is where unfortunately, I don't know how CodeSpeak for content would look like, but I know what CodeSpeak for code looks like. It's when the proverbial maintainer of an open source project is not reviewing the code first and foremost. They're reviewing the intent first. And if the intent doesn't match the direction of the project, you don't need to look at the code at all. And then if the intent is what you like, then you can either look at the code yourself or use a tool to make sure that the code actually matches the intent or whatever. But your primary cognitive load is on the human level, human language level, not on the details in the program level.
Okay.
And that is a much more sensible way of doing it.
I hadn't even thought of it like that. Yeah. So if you're addressing it at the level of the project requirements, like that, you know what the project needs, right? Like you don't need to have, it can be a bad day for you, slow day. You don't want to deal with any code, but if you could still get through a requirements document, that's a lot easier to sort through, right? Like even if someone is a good programmer, it can be difficult to understand the way that another person has written code. And you can have this experience with your own code. You look back at code you wrote 5 years ago. You're like, who is this? Yes. Why? What did you write here?
Yeah, but it's even, I guess it's even harder when you have a lot of code because this kind of PR can contain a lot of changes.
Yeah.
And you may see, like, being a very experienced programmer, you may see a lot of tiny flaws, but you still don't know. Is it even worth commenting on, or should you just discard the whole thing? Because you don't know the intention. There's too much.
Right.
And what you would like to start with is the author of this PR was aware of what the project is doing, and this is their intended change as a diff in your requirements. And if you agree with the requirements, then you can talk about the implementation. But if you don't, you just close the PR altogether, or tell them what the requirements should actually be. And it's a completely different level of communication. You don't really need to look into the code at all if the requirements are not what you want.
Okay. No, I see what you're saying here. I think that's... And when requirements are the code, those requirements are going to be there. This is a problem where, if with the way we currently do code, a lot of people, they'll write out their PR description, but a lot of people are not necessarily good at describing what they've written. So you don't necessarily get that with the current way things are being done.
Exactly. And there is a question of are they using the right terminology to be sort of consistent with how the rest of the project is described? Ideally, what we should have eventually with CodeSpeak in particular is you don't submit the code at all. You submit the requirements and maybe some hints at how the code should work. That's a separate question. We can talk about this. But you don't have to submit the code. I heard about some maintainers actually saying don't submit any AI generated code, submit the prompt. I'll generate it myself. Right? And that's again continuing the analogy of if I'm working on the Linux kernel, I'm not submitting the binary, right? I'm submitting the code that's going to be generated into the binary. And so here, what we're doing, we're gradually demoting code in traditional languages to the status of a binary, basically. And we're not there yet. It will take a long time to fully transition. But mentally, this is what we would like. We would like to not look at the code and look at the higher level representation. So yeah, maybe for a lot of projects, maybe if they have a consistent representation of existing requirements, maybe what the contributor should do is really think through a good change in the requirements, submit that, and have the maintainer actually generate the change in their own agentic pipeline that already is set up to generate good code. That's a possibility. We're not there yet. For a lot of projects, it will take infinite time to set this up like this right now. But the concept is kind of similar, and it's a question of how much of it can be automated right now. But as a human, you would definitely like to start with a well-described meaning of the change, knowing that that's the actual meaning.
Right.
And then discriminate whether you want to look into the code at all or not.
You've given me a lot to think about for this one. I've not done a full AI episode with someone who is sort of this involved. I wouldn't, as you said, you're not necessarily fully optimistic. You're not fully sold, but I think it's interesting that people are exploring the space and what can be done. I don't know, especially a lot of people in the Linux part of the open source space are very anti-AI. There's a lot of disinterest in even experimenting with the tech to begin with. And I understand that. I get it. We talk about compute price, right? RAM price, storage price, all this stuff. Here we go. Let's see if we can get some people annoyed with me. I think 99% of the concerns that people have with AI would go away if RAM and storage didn't go up in price. There you go. Now people can be angry with me. Yeah. That's fine. That's not a joke, by the way. Actually, that is my actual stance. I think if people didn't have to spend 10 times as much on RAM, they actually wouldn't care at all about AI. It would just be another thing.
Maybe, yeah. I think there may be another mechanism to this. No, a lot of people do open source in their spare time.
Sure.
For fun, right? So, and this is your way to have fun. You're used to writing code by hand because you enjoy that. And so there are those alternative tools that are kind of taking the fun away because this is your craft. This is how you were enjoying open source or even closed source, doesn't matter. And now, yeah, so it's this work is considered largely trivial. And what I loved doing is not really worth doing anymore. Or some people on the internet are saying it's not really worth doing anymore. That's offensive.
I get it, yeah.
I can get that.
Yeah, no, I do get it. If you're someone who if what's a good similarity? If you're someone who is an artisanal woodworker, you build these nice, beautiful, handcrafted tables. You love the idea of designing these. That's awesome. I have a lot of respect for people who do that. But at the same time, a lot of people are going to go buy the IKEA table, right?
True, yeah. And I guess it's the situation we're in now is kind of like you're an artisanal wood carver, and someone floods the market with those CNC machined perfect carvings that may look as good as yours, but they have quote unquote no soul because they were made by a machine in bulk. You can crank out 1,000 of them a day, and they're all the same. And yeah, so I get that, and but it's a very sort of complicated thing of motivation, what we're doing this for. If I'm building software to solve a problem and the software is just means to an end, I don't care how it's made. And it needs to work, right? It needs to be reliable enough. It needs to be correct enough and whatnot. but I don't care how it's made. Like the faster the better. Like just give me the right software, and because I'm all about solving the problem. But if my motivation is to be in the process, to like handcraft the software because this is what I enjoy in my free time, yeah, I don't want a tool that replaces me there. Because that was the whole point.
Yeah. Well, I think it's a good place to end it, actually. I think it's a perfect place to end it. Thanks for coming on. Pleasure to meet you and pleasure to talk. And I hope CodeSpeak goes well, and whatever future endeavors you also get involved in go well as well.
Yeah, thank you very much. Thanks for having me, and it was an awesome conversation. I've really enjoyed it.
Thank you. If people want to check out CodeSpeak or they want to check out anything else you might be involved in, where can they go?
So codespeak.dev, we hopefully will be updating the website. Again, I don't know when this podcast is going live.
It'll be a couple weeks.
But we'll be, yeah. So maybe by that time, we actually will have updated the website. Yeah, so in any case, codespeak.dev is your primary source of information. You can subscribe to a newsletter. You can try some things online. You can download some things today. Maybe in 2 weeks, there will be something else to download. But in any case, you can play with everything there, codespeak.dev. You can also join our Discord. And actually, at codespeak.dev, we have this thing that's called Intent Recovery Tool, or Intent Studio even, where you can play with this idea of extracting intent from your agent sessions. So you can upload your sessions, and we'll give you like a set of requirements. We'll give you a spec document that we reconstructed from your conversations with agents. And this is like this intermediate version. That's not perfect yet, but you will get something. You can use it as a baseline working in your project. You can use it with agents just to make them a little more aware of what you're building here. And with time, we'll add features to that, and we'll update live and so on and so forth. So yeah, well, you're all welcome to try this and give us feedback on Discord about the features you like and features you want us to add.
Okay. Nothing else to mention?
Well, there's a lot to mention, but I think we're good for now.
Okay, fair enough. I guess I'll do my outro, and then we'll sign off.
Right.
Okay.
Thank you.
My main channel is Brody Robertson. I do Linux videos there 6-ish days a week. Check that out. You'll see some neat things there. I've got some fun ideas. I'm going to go buy a NVIDIA GT 710 and see what we can do with the $35 GPU. I'm sure we can do a lot with that. No. No, we cannot. I've got the gaming channel, Brody on Games. Right now, I'm streaming Like a Dragon and Shenmue 3. And if you're watching the video version of this, you can find the audio version on basically every podcast platform at Tech Over Tea, and the video on YouTube, Tech Over Tea. We also have a Spotify video as well. I'll give you the final word. How do you want to sign us off?
Well, the world is changing. It's up to us how we fit in the new version of it. And I hope we all have fun upgrading our skills and figuring out how to live in this upcoming world that's being created with our active participation. Good luck, everyone.
Okay.